Hello friends, welcome back to my channel again. Code with me. So in this session of machine learning programming language, we'll be discussing about another interesting topic, that is Navy-based classifiers. So I hope you guys has heard this word Navy-based classifier. So let us learn the in-depth details with an example of this Navy-based classifier. What is this, why it is used, and how it is worked. Okay. So speaking about the definition of what is Navy-based classifier. As per the definition, Navy-based classifiers are a family of simple probabilistic classifiers based on applying Bayes' theorem with strong independence assumptions between the features. In the sense, friends, assume you are predicting something. When you make a predictions, you will analyze that if I give this input, this output will occur. If I give that input, that output will occur. So Navy-based classifier is nothing but you make predictions based on the context that is given to you. But Navy-based classifier is slight difference. The prediction data will be handed over to you before you make predictions. And you will analyze all the data that I have given to you, and you will make predictions based on the data that I have given to you. And you have to make predictions by analyzing the only the data that I have given to you, nothing more, nothing less. And the formula of this Navy-based classifier, which the principal work on, is P of A by B equals P of B by A into P of A divided by P of B. Okay. So speaking about basic example. So this is the common example that I have displayed here. Assume friends, you want to play cricket. Okay. So in cricket, you will check the scenario of the temperature. I mean the climate. If the climate is rainy, you cannot play cricket. If the humidity is so high that it's intolerable to the human existence, you cannot play cricket. If the temperature is extremely cold, hot, you cannot play cricket. If the temperature is heavy, windy, you cannot play cricket. So there are scenario occurs which the temperature is moderate enough to play cricket. Here are the basic charts that these are the moderate climates. These are the basic ethics of the climate has to be there to play cricket. So you can clearly see here, friends, there are 5 divisions: day, outlook, temperature, humidity, wind, and followed by play cricket. In first scenario, friends, so speaking about if the temperature is outlook is sunny, temperature is hot, humidity is very high, and wind is weak, means you cannot play cricket. And speaking about second scenario, if the temperature is sunny and temperature is hot and humidity is high and the wind is strong, you cannot play cricket. So speaking about third scenario, mean day 3, outlook is overcast and temperature is hot, humidity is high, but the wind is weak, you can play cricket. So the goal of this chart is that if you want to play cricket, what are the moderate enough temperatures that you can play cricket? So by analyzing these data, if I ask you a question that if the outlook is sunny and temperature is mild and humidity is high, can I play cricket? So if I ask you about the 15th day of this requirement temperatures, can I play cricket or not? You have to make assumptions regarding that. Okay. So if you ask me, how do you make assumption, means you have to check the probability of every single division here. You have to check the probability of play cricket. You have to check the probability of wind. You have to check the probability of humidity. You have to check the probability of temperature, and you have to check the probability of outlook. Okay. So here's the question, friends. So you have analyzed all the 14 days scenario of that days you can play cricket and cricket. Okay. Question here is the probability to play cricket if the given conditions are temperature is cold, humidity is high, wind is strong, and outlook is sunny. The parameter that is given in the question is not in the chart. So you have to find out the question: if the temperature is cold, humidity is high, wind is strong, and outlook is sunny, can I play cricket or not? So the question here is, can I play cricket with these above conditions? So here is the question. If you want to know the answer, friends, request you to kindly please stay till the end. So you will have the in-depth details of how this exactly Navy based classifier works. Okay, so speaking about first probability of yes and no. You can clearly see here, friends, in the column of play cricket, there are no S, no S, no S, no S. Okay, so there are a total of 14 days. Okay, in these 14 days, 9 days I can play cricket. Okay, and followed by 5 days I cannot play cricket. So speaking about the probability of yes, that out of 14 days I can play 9 out of 14. So the probability that I can play cricket is 9 out of 14. Like the same way, the probability that I cannot play cricket is 5 to 14. So here in this slide, friends, you can clearly see here I have checked the probability of playing cricket. So next, so let's skip to the probability of wind. Okay, speaking about the probability of wind. This is the basic formula. Probability of yes equals 9, probability of no equals 5. So I request to kindly please remember this formula right till end of the video. I will let you know why. Okay. So speaking about wind, there are 14 scenarios, 14 days. In 14 days, some days wind is weak and some day wind is strong. Okay. So out of 14 days, 8 days the wind is very weak. Okay. And 6 days the wind is very strong. Okay. Out of 8 weak winds, there are 6 days I can play cricket with weak winds, and 2 days I cannot play cricket with weak winds. So, speaking about the same strong winds, there are 3 days I can play cricket with strong winds, and followed by 3 days I cannot play cricket with strong winds. So, speaking about the probability of weak winds that I can play cricket is probability of wind by S. Here you can see here, instead of writing 6 by 8, I have written as 6 by 9 because, friends, first comes the probability of wind equals 6. Okay, the reason I have written here 9 as the probability of yes, you can see above here, probability equals 9. So I written as 6 by 9. The reason here, friends, so in order to play cricket, I will not just consider the wind, I have to consider all the scenarios: outlook, temperature, humidity, wind, and play cricket. For that reason, I have recorded as P equals W of 5 equals 6 by 9. The same goes with no, that will come out as 2 by 5. So speaking about the same thing with strong, probability of yes that I can play cricket with strong winds is equals to P of S of 5 equals 3 by 9. And same goes with no, P of S of n is equal to 3 by 5. Okay. So now here come across the probability of wind. Now let's skip to the probability of humidity. With the same motion, with the same formula, just to remember, followed by probability of humidity, there are 7 days I can play cricket with high humidity, and there are 7 days with normal humidity. In these 7 days of high humidity, 3 days I can play cricket with high humidity. Okay, and 4 days I cannot play cricket with high humidity. And speaking about normal humidity, friends, 6 days I can play cricket with normal humidity, and 1 day I cannot play cricket with normal humidity. So speaking about the probability of humidity that I can play cricket is equal to 3 is to 9. So the probability that I cannot play cricket with high humidity is 4 is to 5. Probability that I can play cricket with normal humidity is 6 by 9, and probability that I cannot play cricket with normal humidity is equals 1 by 5. So speaking about next, the probability of temperature. There are 14 days temperature, but in this temperature division there are three parameters. One is hot, one is mild, and another is cold. So 4 days with hot temperature, 6 days with mild temperature, and 4 days with cold temperature. Okay. So in this hot temperature, 2 days I can play with hot temperature. Okay, and 2 days I cannot play cricket with hot temperature. And 4 days I can play cricket with mild temperature. 2 days I cannot play cricket with mild temperature. And cold, 3 days I can play cricket with cold temperature, and 1 day that I cannot play cricket with cold temperature. So speaking about the probability of hot that I can play cricket is 2 is to 9, and no for 2 is to 5. And speaking about the probability of that I can play cricket with mild temperature is 4 is to 9, and no 2 is to 5. Same goes with cold, it will become 3 is to 9, and no comes with 1 is to 5. So speaking about temperature, probability of outlook. Okay, outlook what happens? There are 14 scenarios. See, there are three scenarios. There are 5 sunny days, 3 rain, 3 rain days, and 4 overcast. So speaking about the probability that I can play cricket with sunny outlook is 1 day, and 4 with no, and 4 days with rain, and 0 with no overcast, 3 with this, and no with one. If I check the probability of sunny that I can play cricket is 1:9, and I cannot play cricket is 4:5. And probability that I can play cricket with rain is 4:9. I cannot is 0. Okay. And speaking about overcast, I cannot play cricket is 3:9. I cannot play 1:5. So friends, now here what happens? Speaking about final probability, now we have come across the probability of wind, all the variables, all the values, and probability of humidity with all the values, and probability of temperature with all the values, and probability of outlook with all the values. Okay. So the question was, find the probability that I can play cricket if the given conditions are temperature is cold, high humidity, strong wind, and outlook sunny. Okay. So let's put all these variables into X. X equals sunny, cold, strong, and high. So using the formula as you have shown in the first slide, you keep probability of X by S, probability of S into probability of sunny by S into probability of cold by S, and probability of high by S, and probability of strong by S. And same goes to the probability of no into probability of sunny by no, probability of cold by no, probability of high by no, and probability of strong by no. So doing the call calculation probability of S, formula I have seen before. And if I add the values, you'll get somewhat like 0.0053. Okay, and calculation of this probability of no that I cannot play cricket on the given conditions, that is, you'll get somewhat like 0.0205. The question, friends, we have come to the conclusion that probability that I can play cricket is 0.0053 and probability that I cannot play cricket is 0.025. So how do we calculate that we can play cricket, yes or no? It's very simple, friends. You have to compare the values of probability of S and no. In this scenario, what happens, you can clearly see here the probability of no is found to be greater than S. So friends, the final answer is no, that we cannot play cricket for the given question that was meant to be. Okay, so before exiting the video, friends, request to kindly please uh, pin down your comments if you have any doubts regarding the Navy based classifiers. And if you like this video, request to kindly please like, share, and subscribe. Thank you very much, friends. Have a nice day. Keep coding. Love you all. Bye.